Welcome back, ladies and gentlemen. Tonight we are going to talk about probably one of the most consequential branch of mathematics in modern physics. Yes, I'm talking about the study of symmetry in physics and consequently the study of groups. So, before I start to talk about the definitions of group, as always, I'd like to motivate the discussion by presenting some of the cases where we actually do need the study of groups, and then we'll probably start talking about groups by first defining it, and then talk about the applications and the examples of the study of group. So off we go. So we'll talk about groups in probably all the branches of physics. For example, we can start talking about the applications of groups in classical mechanics by considering a system that poses a certain kind of symmetry. So for example, if we talk about a two-body problem and we are talking about the presence of some sort of force and consequently and hopefully some sort of potential, then that potential is a function of the positions of both of the particles. But more often or not, we'll notice that it actually depends on the relative separation of these particles and not the absolute value of the positions. So, immediately we notice that it represents some of the symmetric features for the potential. So, for example, just from the looks of the outside, we notice that this potential would be rotational symmetric. Plus, this would possess the additional symmetry with respect to translations and reflections. Probably the most widespread applications of groups started taking place by the hands of Eugene Wigner in the 1930s when he started applying group theory on quantum mechanics. And you'll notice the applications of groups in quantum mechanics all over the place. One of the most readily presentable instances is probably the energy of the ground state. So the energy of the ground state displays almost all the symmetries possessed by the Hamiltonian. And if we start talking about rotations and angular momenta, that's just purely the display of the prowess of groups. So angular momenta. And then, of course, in the more fundamental levels, we have quantum field theory, which shows the generalization of the concepts and applications of groups in quantum mechanics. And we generalize that to the study of the symmetries of the fields. So fundamental particles, to understand them and to detect them, groups play an enormous role, which is primarily the goal of studying groups. So in quantum field theory, particularly in particle physics, symmetries and symmetry breakings are probably some of the most spectacular features which help us to navigate this field better than we probably could think of without the application of groups. So that's just a very, very limited and restricted discussion for motivating the study of groups. So allow me to now dig into the actual study of groups, where we define what is group and probably some of its examples.